right, lesson 3. We're going to talk about multiplying and dividing monomials. Let's dive right in. Okay, so what is a monomial? Let's kind of remind you what that means. So examples of monomials are things like 5 or 6x or negative 32xy or 5xy squared. Those are all monomials. What would be not a monomial? Something like x plus 5. That's not a monomial, right? So things that just have one term, right? It's only got multiplication. There's no addition. So those are monomials. So that's what that word means, right? That's not going to factor in too much, but just to make sure we're staying clear in our head of what the words mean so we can know what I mean when I say things and when you read things and all the things, right? So first thing we're going to learn is the product property of exponents. And I like to say when we have like bases multiplied. So like base ace. Oh, that should be like bases multiplied, but I wrote two different bases. That dog ain't gonna hunt. That dog ain't going to hunt at all. Now let's grab that and change that to an A. There we go. Like bases multiply. That works out now. Great. So if we have a to the m, some base to some exponent times the same base to a different exponent, what we do is we add those exponents. So we have like bases multiplied. We add the exponents. So kind of like this little example here. So we've got like bases. They both have 2 in the denominator, or not the denominator, down in that base, right? 2 to the 4th times 2 cubed is the same as 2 to the 4 plus 3. So say we added these two exponents, which would be 2 to the 7th. Let's do some examples with this. So we're going to find each product. I don't know why I'm having trouble with products and properties and poplars. I don't know why I'm having trouble with those words tonight. I'm tired. Find each product, express using exponents. Okay, so we've got like bases multiplied. What are we going to do with the exponents? We're going to add them. So this is going to turn into 4 to the 3 plus 5. And we can go ahead and clean that up. 3 plus 5, of course, is 8. And we're going to leave this as 4 to the 8th because we want to express our answer using exponents. Now, this next one is a little bit sneaky, right? Because this one, there's nothing up there. So what is the exponent? Is it 0? What is it? No, it's not 0, right? Because anything to the 0 is 1. Anything to the 0 equals 1. So that wouldn't be it because that would just like go away. So that can't be true. So what it is if there's not an exponent there, it's to the first, 6 to the first, right? So in this case, we would add those exponents. So this would turn into 6 to the 1 plus 4, which would be 6 to the 5. All right, let's do another one. Oops. All right, we're going to find each product. So again, we have like bases, b squared times b squared. They're multiplied, so we're going to add the exponents. So this b is going to turn into b to the 2 plus 2, which of course would be b to the 4th. Easy peasy. Now, this one looks scary. There's all kinds of stuff going on. It's not that bad. Okay, so first we got two types of things going on. We've got these what are called coefficients in the front, right? These numbers in the front. What do we do with those? Well, those we can just basically rearrange it and multiply. So 2 times 8 is 16. So the numbers that are not exponents, you just multiply, right? So then we've got like bases multiplied. I'm going to write that down here. You should do the same. X cubed times x to the 4th, right? So now we've got like bases multiplied. What are we going to do with those exponents? We're going to add them. So this is going to turn into 16 times x to the 3 plus 4. So it's going to turn into 16 times x to the 7th. All right, let's learn one more little property real quick, and then we'll do a couple more examples, and then we'll be through. It's going to be a quick one today. All right, so we looked at the product property, so like for multiplication, like bases multiplied, the quotient of powers property, so like bases divided, and I wrote it both of these ways, mostly because the book gives some examples with this notation. A lot of the time, a good chunk of the time that you see this in a textbook or whatever, you're going to see it more like this type of notation. But I wanted to include this just so you wouldn't get confused when you saw it a different way. So if we have a to the m divided by a to the n, which could also look this way, we subtract the exponent. So if we have like bases divided, the exponents get subtracted. So like this example right here, written both ways, 3 to the 6th divided by 3 squared, we subtract those exponents. 3 to the 6 minus 2. Now you notice it's this top one, or the first one if it's written this way, first. And that's important because subtraction, it matters, right? The direction. 6 minus 2 is different than 2 minus 6, right? And so it's important that we keep that in the right order. And then 6 minus 2, of course, is 4. Let's do a couple examples, and then we're going to be finished. All right, we're going to find each quotient. So we've got like bases divided here. They both have 8 as the base, so we're going to subtract those exponents. So this is going to turn into 8 to the 5 minus 2, so that would equal 8 cubed. All right, same thing over here. We've got like bases divided. We're subtracting those exponents, so it's going to turn into the c to the 7 minus 2, which would equal c to the 5th. And that is actually it for that lesson. It's a pretty quick one. It's not too bad. A little bit tricksy. Make sure you're only doing with the bases that match and all that kind of stuff. They'll get more complicated later in Algebra 1 and all of that. But that is it for now. We will see you in the next lesson. Y'all have a great, grand, glorious day. Bye-bye.